Hello, everyone. This is Giacomo Beccari speaking, and on behalf of the ESO Office for Science, I'm happy to welcome you all to the last day of our Astro 2022 conference, the present and future of astronomy. Thank you very much for being with us, and thank you to all the speakers that contributed to make this series of events really successful and so enjoyable. Today, the topic of today, Astronomy and Society. This is an overview of the program of today. As every day, I remind you that there is part one, which ends around 3:30, and then there will be a coffee break, and then we will start again at 4. So, the people on YouTube will see the broadcasting stopped, but then we will resume again at 4 o'clock. Please go back to the main channel, then you can join again the event on YouTube. Some general points that I want to make. As every day, please be reminded that you can participate into the discussion. So we have at the end of the day, we have a 1 hour of discussion, and you are all welcome, of course, to make questions to our speakers or make comments and to contribute to the discussion, which we acknowledge it's when we are in a digital, in a web environment, it's not easy, but it's something that we enjoyed a lot in the past days successfully, and we thankfully also to all our chair and moderator who are making a fantastic job really in making all this possible. And the contribution from people is absolutely welcome. Specifically, I stress every day the early career scientists, we are here to hear you. Please feel encouraged to speak up, to say your opinion, to make your questions, because you are giving always a fundamental contribution, an original contribution that we want to learn from. The registered participant, you can contribute by and make the question by raising your hand inside Zoom, or you can also write the question on the chat, and then the moderator will read it, or we will be asked to make yourself the question. So in that case, please be patient 1 second, that you will give the possibility to unmute yourself, and then you can make your question. Kindly, also, if you feel comfortable with that, you can also turn on your camera and introduce yourself, and then make the question to the speakers. People from YouTube, they can also participate, and by putting the question on the chat, and we will pass the question to our moderator. If you feel like if you want to make your question by remain anonymous, this is absolutely fine, of course, and you can do it by sending the question to using the online form that is available on our Astro 2022 pages. You can write your question, send it to us. We will pass it anonymously to the moderator. Please be reminded that, as I said at the beginning, this event is streamed live on YouTube. So we please be aware of this. If you feel uncomfortable, especially people in the Zoom meeting, if you feel uncomfortable with that, we ask you to please leave you can leave the event, and you can still follow the event later on YouTube and watch it completely on YouTube. So with that, I would like just to remark, finally, the ESO code of conduct. This is very, very important. We at ESO trust in making and creating a comfortable atmosphere where all opinions and comments are absolutely welcome. But we trust that to make, as it happened so far, we trust in having a comfortable environment for everyone. So please behave professionally, show tolerance to opinion of others, and respect to the opinion of others. There are 2 contact points, myself, Giacomo Beccari, and Anna Miotello. So all participants should feel free to report violation of the conduct of the guidelines to Anna and myself, and we will treat this in full confidence, of course. With that, I would like to thank you all for being with us. I would like to thank already the participants. I would like to thank the speakers, and of course, I would like to thank Bruno, who is our moderator today. Bruno is a staff astronomer at ESO. He's a fantastic, extraordinary person and a great scientist. I don't know. There are no words to introduce Bruno, because Bruno, you are our reference, basically. So thank you for moderating, and thank you for helping with us, and thank you also for your contribution in shaping the conference And with this, I will leave you then the floor to introduce the speaker and to start the event. Thank you very much, and see you later. Enjoy, to everyone, enjoy the event. Thank you.
Thank you, Giacomo. I'm just a moderator. So let me just also mention, we had planned that Selma de Mink, who's one of the directors of the Max Planck Institute across the street here in Garching, also would co-chair this session. She will join a little later, as it is with so many of us. There are overlapping commitments. So welcome to the 5th day or half day of this conference that sort of reflects on who we are, what we do, and how we treat each other. And so we looked at the methodology of science of astronomy, and on the first day, we had some discussions on how we're funded, how the society funds us. We then looked at evaluations, how are people evaluated, what does it mean to progress within our profession. Yesterday, we had talks on mental health, especially for young people. How are the difficulties that we deal with within our jobs, within our research. And today, we're going to sort of open this up to us in society. So we are part of the society that supports us, but we also have something to give back to the society. And so the talks that we hear in the following will first deal with how we return our excitement and knowledge to society. And then later we sort of focus back on ourselves and how are we as good citizens, or what should we do as good citizens of this world. So the first speaker is Sandra Benitez. She is somebody who's traveled wide and far. Many of us have traveled wide and far, but she spent time in very different places. She studied in Spain and then studied here in Germany as well. Later, and as part of that, she spent some time in Chile. And then she worked in Brazil for several years, and she's now coordinator at the Communications Outreach Department of the Astrophysical Institute of the Canary Islands. And she will tell us about how we can take our knowledge into the classroom and return this to young people. So Sandra.
Hello, everybody. And thank you so much, Bruno and Giacomo, for the invitation. And thank you for organizing this workshop, which I think is so fundamental to discuss all these different topics that have been discussed during the week. Today, I'm going to present some ideas of why astronomy is so important for education. So let me just share my screen. And let me know if you can see it properly, please. Yeah, okay, great. As Bruno said, I've been working for the past 10 years or more with teachers and students, trying to convey different messages through astronomy and try to motivate the youth to understand and to be more interested in science through astronomy. Currently, I work at the Department of Outreach and Communication in the Canary Islands, but actually very soon I will be joining ISAC in Madrid, also as a science communicator and educator. But today I want to share some activities, some experiences that I had in all this time, and try to reflect on why should we have astronomy in the schools, why astronomy for education. First of all, as we all know, we have a great advantage, which is the unique visual power that we have in astronomy with all our very impactful images that we get through our telescopes. And this is an advantage that other science may don't have. And it's incredible, the feeling of awe and admiration that it provokes in young children and youth as well, also in adults actually. So it's very impactful, and it's a resource that we have at hand and that we can use in schools, trying to improve somehow or get more students interested in science. The same applies for starring staring at a starry night, for example, so going in a dark place and looking at the sky. This is the same sort of inspiration. And actually there are some articles, some papers about the benefits of enjoying dark nature, which is not only being into nature, which we already know it has some benefits for our body, but also to be in dark nature where we can actually contemplate the sky. And of course, we need to bring this to the schools. Also, astronomy, not that other science don't try to answer relevant questions, but astronomy is trying to answer maybe some of the most profound questions, like, are we alone in the universe? How did the universe started? And what is going to be its destiny? So we can also engage the students with these big questions that probably they have also thought about at some point in their lives. So this connects somehow to our human side. And on the other hand, astronomy is a gateway to other sciences that might be a bit more difficult to grasp, maybe more difficult to present. But through astronomy, we can actually get students to be more interested, more motivated to approach other sciences. So this would be like the main three motivations to include astronomy in schools. And it's also extremely connected to the curriculum, actually. So because astronomy is so multidisciplinary, we do physics, chemistry, biology. There's a lot of maths in it. There is, of course, a lot of computer sciences. We are all the time working with engineers to develop all our telescopes and instrumentation. So this multidisciplinarity is very, very important and very interesting to work together with the schools. There are several organizations that have been studying the curricula over the past decades, like, for example, Núcleo in Portugal, Galileo Teacher Training Program, also in the UK, the National Schools Observatory, or here also at the Canary Islands, we have a big department trying to understand the curricula. And what we see is that astronomy is transversally appearing basically in all levels of education, even in primary levels, secondary. So it's a very important tool that we need to use. Even some institutes, for example, here in Spain, they do have a specific subject on astronomy, but even if this is not the case, astronomy is everywhere in the curriculum. And the problem is, and I will comment this a bit later, that teachers, they usually don't have the tools to actually address these topics in a practical way, in an entertaining way. So sometimes they just lack the resources. So this is also why it's very important to work with them so they can be prepared to actually taught these or teach these topics that are in the curriculum. Not only that, but astronomy can also be an excellent educational resource to other disciplines, such as history, art, philosophy. So it's also a great connection to other, so to say, arts disciplines. And for example, in the educational department here in La Laguna University, there is a group of people that is doing exactly that. How can we use astronomy, not only to teach physics, which is quite obvious, and there's a lot of materials about that, but how can we combine this with art, or how can we teach history through the history of astronomy, for example? So this is all very interesting. And there are many other studies that are trying to really understand the curricula across different countries. And again, as we see, astronomy is there. And that has been also an effort by the IIU Office of Astronomy for Education to cover different educational systems and see in a systematic way what is being done, at least across Europe and increasingly other countries. So this is an ongoing effort that many of us are working on. Astronomy also links with the technological advances, of course, and it's important that the students understand how this technology can actually bring a benefit to their life, to their daily life. So there are several resources that we can also use in the classroom, like this booklet from the IIU that tells you, for example, how image analysis software is used also for medicine purposes, or any other developments that we are doing in astronomy. So it's very important to also tell that to the students so they can actually see the science and astronomy is something that is in their daily life. It's not something that is disconnected from them, but it's really in their daily life. And astronomy has this other aspect that almost all folks in Earth have looked at the sky, and so there is this deep connection also with the culture. So we can also intervene in this way to make students to understand how in their culture astronomy is also present. So we can also have an exchange in this sense. And for example, here I show you some pictures. The first one is a work that we did at indigenous communities in the north of Brazil, where they were actually explaining us how the moon formed, so their own legend of how the moon formed. And then we were discussing our view with modern astronomy, and the students were immediately more interested because they started from something that they actually knew about and were related to, and then they were curious about knowing something new. And the same for the second picture is when we went to Western Sahara to do some work at schools there, but also to talk to sages that actually have been using the stars for many purposes in the desert, like for example, to guide themselves through the sand dunes, also for calendar, like they still have the calendar, the ancient Arabic calendar is still used there in the camps, or even for religious purposes to mark special dates. So the idea is that you will develop resources that maybe start from this point of view that the students already know and they are familiar with, and then you go further towards the knowledge that we have as professional astronomers. And because of all these qualities of astronomy, because it's very approachable, because it's really something that talks to us as humans, as social groups, we can actually reach different publics. We can talk to underrepresented groups. We can talk to high-risk youth, for example. This is a project that I really liked a lot. The picture you can see with all the people with the cap, all the children with the cap. This was a favela in City of God, so in Rio de Janeiro. And they were actually taking pictures of Mars with a high-res camera controlled by NASA. This was a project by NASA. And they were so amazed that they could do this. It was really instantaneous, basically. The motivation for science increased a lot. So we can actually really reach publics and people that you wouldn't think at the very beginning. And I think astronomy is a very powerful tool for that. And I'm not gonna go into details because I know my colleagues are gonna cover this, but just as a very important message that we need to bring to schools is also something that astronomy tells us, that we are all under the same sky, and with astronomy we can develop some kind of global citizenship. We can promote peace amongst different cultural groups in different countries. And this is something that also we can explore, and we can talk to our students about that using astronomy. And the same goes for climate change awareness. And I know Leonard will talk about this later, but it has been proven that talking about astronomy from the pale blue dot perspective actually changed the attitude towards the planet, towards taking care of our planet and being more responsible or feeling more responsible. And this is very, very important also that we bring to the schools. And while in general, astronomy is very attractive, it's in the media as well. It's almost every day there is a news about something related to astronomy or space sciences. So again, it's in the daily life of the students, and we can also take advantage of that. I want just to go maybe a bit more into details about what we mean about education. Here, I'm talking all the time about formal education, something that happens within an institution, a school, an institute, even a university. Is of course hierarchical and is chronological ordered, but education can happen in other formats as well, like for example, a museum of science, even a theater, if there is a scientific theater piece there, different venues where educational activities are organized outside the curriculum. So the topics there are much broader. That you don't need to actually be connected to the curriculum, but this is also something that we call non-formal education. And informal education is something that happens during your life based on your daily experience, your influences from the family, from your environment, and it's something that we can also use to somehow communicate astronomy. But I will be focusing today on formal education. And this is something that is very general for science communication, but I want to talk about this because during a lot of time, we scientists, we have been using this model to communicate with the people, which is called the deficit model, where basically we have the knowledge and then we are somehow filling a void of knowledge that the public has, and we consider that they are ignorant. And this is an approach this unidirectional. We have the truth and we are sharing this truth. And sometimes you see this in the way science is taught at schools as well, even at universities. So it has been an evolution, a very, very important evolution to incorporate the knowledge of other people, as I already talked, for example, from indigenous communities. But the important key here, or the key part here, is that we establish a dialogue. We establish a dialogue with the students, with the public in general, and we empower the communities also to participate in science. So now what we actually talk about is about public engagement in science. So it's not only science communication, we are not only communicating, but we are also talking to them. We're having a dialogue. The people are participating, and we scientists are accountable for our work, because at the end of the day, most of the science is done with public money. So we really need to be out there explaining what we do also in our schools. So sometimes I'm asked why young people is now interested in science. And actually what studies are telling us is that they are actually interested in science, and actually point 5 shows that the interest in out-of-school science and technology activities is increasing. So there are more children going to science museums and going to star parties and going to activities outside the school, but the in-school science and technology interest declines considerably. And this is, of course, causing that less young people is enrolling in scientific careers, although overall, there are more and more people enrolling in university degrees, but not in scientific careers. And it seems to be a connection between this attitude towards science with the way science is taught at schools. And of course, we know it's really difficult to innovate within, again, something that is already institutionalized, that you have your times to cover many different topics, but maybe with different approaches, we can actually reverse this situation. And usually the approach is a deductive one. So the teacher is going to present concepts, the students have to believe it, basically, and they have to memorize some dates, formula, and they consider like science is a well-established truth, and they don't have anything more to participate in. They don't have anything to contribute to. If you combine the power of astronomy, all the qualities that I mentioned, with inquiry-based learning, which is a new technique, there are others, but this is a technique basically that puts the student in the center and makes him or her be the one that is doing science. So it's learning science by doing science, then things can maybe probably change, because the student is going to wonder, it's going to investigate, it's going to discover, it's going to reflect, it's going to fail. It's very important to tell the students that we scientists are failing all the time. So it's not like you go to your lab or your telescope and then you have this eureka moment and you discover groundbreaking discovery. No, it doesn't work like that. It's a lot of work, a lot of fail, but from that you start learning. And usually I have seen that students don't have this idea of science. So I like a lot these sites. One is attributed to Confucius, that tell me and I will forget, show me and I may remember, involve me and I will learn. So people learn by doing. This is a fact. you can try to memorize as many things as you want, but by doing is when you are really going to be touched, so even emotionally, and then you're going to learn. And students learn not what they are taught, but what they remember, and they remember what it is relatable to them, what is familiar to them. So with this inquiry-based learning approach, students are confronted with a curiosity, with a problem they want to answer. How can we study if there is life in Mars, for example? Or something as simple as, well, we have been told like forever that planets go in elliptical orbits, but I want to prove that. Okay, I know this has been done there for 400 years, but I want to prove it now, okay? So how can they actually prove these kind of things by themselves? So they're going to make questions. They are going to work together with other peers also to demystify this idea of scientists as a genius. So we now all collaborate, we work together. They design their experiments, they arrive to their conclusions, and they also share with the community. And the important thing here is that using astronomy plus inquiry-based learning, you are not only learning about astronomy and astrophysics and what galaxies are, but you are also learning to think critically, to solve problems. You are learning creativity, you are being creative when you are solving these issues, these problems, and this is meaningful to them. Again, astronomy is the perfect science to do this because you will have the whole universe as a laboratory, basically. It's a cosmic laboratory that you can actually bring into the classroom in very different ways with online resources, bringing a telescope to the classroom. If you are lucky enough to have an observatory nearby, bring them to the observatories. There are many, many things that you can do. I don't have much time, but I also want to mention that astronomy, even though there are many things that need to be worked, is one of the scientific disciplines that have more amount of women. So we can also go there and break stereotypes about what a scientist looks like and talk about diversity. And for example, we had this project called Girls in a Museum when I was working in Rio de Janeiro, and there were group of females, of young females, many coming from disadvantaged neighborhoods or favelas, and they had never heard about science or anything else. But we were talking about different disciplines, not only astronomy, related areas as well, during a year and a half. And after this whole process, they were designing activities, outreach activities for the public in the museums. They were the ones that were putting themselves there to talk about science. Somehow they were empowered to talk about science and other female scientists from the past. We had an activity about this. And the idea is also basically that you can empower students not only to learn science, but being able to talk about science. And for this, of course, I haven't mentioned, teachers are a key actor. So it's so important that you work with teachers constantly, continuously offering programs for training, whereas it's more practical with telescopes, or more theoretical or more didactic, so based on the didactics. And I think this is something that maybe all the organizations, scientific organizations, should think about, to have programs led by our own scientists or the science communicators in-house to prepare these workshops, because it's very, very important for them. As I mentioned before, the teachers sometimes, they don't have the skills, they don't have the time, they don't have the, they don't even know where to look for information, because there is so many things in the internet. So it's very good to actually give them the resources, if it's possible, to be able to be addressed at the classroom.
Sandra, 10 more minutes.
10 more minutes?
Yep.
Okay. I thought I was even worse with my time. So great, thank you so much. Now here I'm just showing some pictures of trainings that we did, for example, in the Canary Islands. We were in collaboration with a museum of science, and we were having like one scientist expert, for example, in star evolution or in galaxies or even in cosmology, talking to them, presenting the latest results. And then we had 1 hour strictly for didactics. So how can we apply this knowledge and we can bring it into the classroom? What kind of experiments we can actually do? For example, if you are trying to talk about black holes or about gravity, what kind of things we can bring into the classroom? Of course, then with COVID, we had to convert everything online, but even though we were trying to keep this practical approach, and you can see me here actually extracting DNA cells, so the DNA molecules from tomato cells. This is a very cool experiment that you can do in 10 minutes. And it's not only for the biologists, it's also for the chemists, for the physicists, because at the end we are trying maybe to explore how the rovers are going to do in Mars, right? How they are going to look for life there. So this a similar experiment, an analogy that we can do also in the classroom. And here, for example, you see some pictures that also when we were to Western Sahara and we brought equipment that they are not able to acquire, like we brought telescopes, we even brought interferometers, the LIGO collaboration, the Virgo collaboration, sorry, they donated some interferometers, and at the beginning, it was a bit strange for the teachers, but after some training, they were actually able to use it for the optics and physics practice. Another initiative that we had also within the Amanar Under the Same Sky project, which is a project again for the Sahrawi refugees, is, for example, to do a training with teachers using WhatsApp, because COVID was there, we couldn't actually travel to the camps. They don't have stable connections, they don't have computers, but they do have mobile phones and they have WhatsApp. So we were preparing all these different kind of materials, audio, some very short videos. We were translating it to Arabic, and then we were sharing this towards WhatsApp. And it worked perfectly. So we had 25 teachers engaged through 3 months having this training, and also refreshing how all the materials that we had led the year before, all the materials that we had donated, refreshing how to operate them and how to use them. So the important thing with the teachers is always to be in constant communication and provide them materials in a constant way. And very important also for all the projects that are related to education is the evaluation. So for example, I've been dedicating a lot of time evaluating the teacher trainings to see if they are relevant to the teachers, if this is really what they need in order to address all the different topics they have to address. And on the one side, what you would do is to ask them about the different expectations they have about a course like this, and also then check after your training has finished how these expectations were actually met and if they actually got what they needed. And well, in general, for example, from the work that we did here in the Canary Islands, we had a very positive feedback. Basically, what they wanted was to learn about astrophysics more for a personal level, and also learn how to operate a telescope that they could use with their students. So this is something that we provided and that it was fulfilled for them, but also it was very important for them to know real scientists. So again, it's very important that we put ourselves as professionals out there, not only for schools in general for outreach, but for the students. It's really, really important to see role models, to see scientists of different genders, of different races. Of course, diversity is the first thing, but to be there in the schools, it's very important. So we can really be role models for them. And then it's important if the scientific institutions, they have departments of communication and outreach, it is very important to develop educational resources that they can use, because it is not enough to give a talk about cosmology, which of course they're gonna love, but it's how they apply this then in the context of their classroom. So it's important to have this development of educational resources. And I think I'm gonna finish here. I think there will be some discussion later. So if there is an open question or anything, we can talk later. Thank you so much for your attention.
Thank you, Sandra. Excellent. That's very wonderful introduction into the topic. There are questions. Let me see. So we have a question in the chat. I actually prefer that people ask the questions themselves. So Giacomo, if you could unmute Jitendra Joshi. The other option is that you raise your hand within Zoom so that you come to the top. So, yeah.
Yeah, myself is Jitendra Joshi. I just want to ask you how this teachers can involved in the active research, because ma'am told that teachers' participation is very important in all these aspects. So if teachers are involved instead of only workshops or training, so if it is like active research, if they are involved, so it will be more like beneficial for teachers and students also.
Yeah, absolutely. I haven't mentioned that because of the time, but for example, here at the Canary Islands, we have one project that is called Peter, and they use the Liverpool telescope that is in La Palma, and they give 3% of time for educational purposes. So actually teachers together with their students can apply for time for the telescope. They can observe a variety of objects, galaxies, variable stars, planets even, to try to discover extrasolar planets, sorry. So this is very important, not only that we give them the resources, but that they together with their students can actually participate also in scientific projects. And also in this direction, it's a bit like citizen science. There are some kind of projects of citizen science for the schools, so they can actually contribute. That this is already being done. If anyone is interested, I will post the website of this project because it's really good. They have a lot of materials and it's very easy to get observations from the Liverpool telescope. And I'm sure in the National School Observatory also have resources about the robotic telescope that you can actually use for that purpose.
Thank you. The other question that we have is from Alessandro Ederoclite. I know you, Alessandro. So Alessandro.
Hi, Sandra. First of all, thanks for the phenomenal, inspirational presentation. Taught me a lot of things. My question is actually the opposite of the question you just got. How important was you to be a researcher, to have a PhD and have had your own background in research to become a scientific communicator and to work as a science communicator? Thanks.
I think it's very relevant, but I also know science communicators that don't have a background in astrophysics or in science that are absolutely excellent. So it's not mandatory, but of course for me it was very easy to do the transition because you have already the knowledge. And I know, for example, other people have to actually study the topics they are communicating about. But what I would say is that it's even more important that even if you have a PhD in astrophysics, that you get some kind of degree or some sort of training in science communication or in education. So for example, while I was in Brazil, I was doing a master's in outreach of science and technology, and that was the key for me. So it's very important that we scientists also, maybe when we move towards speaking with the public, we also try to be professional and maybe have an according degree in that.
Sandra, I'd like to follow up on this. How important do you think would it be to have some training for professional astronomers before they talk to the public?
I think it's very important. I think it's crucial.
And yeah,
not because they are gonna do it in a wrong way. Probably they're gonna be very, very good speakers because we're used to speaking in public. But maybe it's something to train about the language, about the attitude towards questions. It's not the same to get a scientific questions where you have to defend your work when someone asks you from the public. Things like that are very subtle. I think it would be very interesting to have training.
Yeah, I think I completely agree with you. It took me probably 2 decades until I understood this. We have a question by Dante, or actually a comment by Dante. So it would be good if we could hear that. No? There he is.
Hi. Actually, these are fantastic. I mean, the work that you're doing is excellent. But there are many activities like this going on. But how can we make it massive? And I think ESO, for example, IAU also have a huge role in making this known, not for 40, 50 students, but for hundreds of thousands of students all over the world. So, but this is hard. I have not figured out how to do this. We are trying to do this in Asteroid.com in South America, but it's really tricky. I would like to know if you have some ideas about that.
Mm-hmm.
Thank you.
Thank you for your comment. I think that you are totally right. We still have a lot of work to do trying to do this like even more global effort. But since I started doing this, I have to say that a lot of advances have been done. The IIU is really putting a lot of effort opening the offices for outreach, for education. So really developing a lot of resources. And now, for example, it was just announced a couple of days ago, the prizes, they're going to be every 3 years for outreach, education, and astronomy for development. So 3 different prizes for this. Of course, many things are to be done. ESO, for example, was the one that in the International Year of Astronomy was one of the institutions that was leading the efforts for science communication, especially in South America with the Galileo Mobile. They were one of the supporters and sponsors for the work that we did there for 2 months. Actually, we were in different countries in Bolivia, Peru, Chile, of course. And we were covering many different rural areas, reaching thousands of students. But again, it's not enough, and we need to do even more. And I think here, maybe for the discussion, we can leave it, is where we reach the political level. Of course, we as scientific institutions, we can do as much as we can, but there at some point has to be a national effort. So we have to also talk to the politicians and convince them that this is important.
Very good, thank you. So this is yeah, there's plenty of material to discuss later on. Thank you. I'm sorry, I want to stop the discussion now. I've noted the 2 further comments that we have in the chat, and we want to pick them up in the discussion later on. So Sandra, thank you very much. Excellent introduction into this topic. So we'll move on. We have the next speaker is Annalisa De Gia. She's a professor in Geneva, and she's also traveled a lot around Europe and the Mediterranean, I'd say. But she's been working on a number of interesting topics, and today she's going to tell us, I guess, her views on astronomy and society. So Annalisa, I'll give you 15 minutes, and I'll 5 minutes before the end, I'll speak up. Okay?
Thank you, Bruno.
Yeah. Oops.
You see my screen? So thank you very much, Sandra, for a very inspirational talk just before mine. I really also learned a lot. It was really good. And I would like to thank the organizers for organizing this very special conference. It's indeed an important discussion that we're having. And well, today we'll talk about why is astronomy important for society. First, why? Asking why. Well, I heard way too often that astronomy is it's cool, it's fascinating, but it's kind of a luxury, and it's basically a waste of taxpayers' money. And I heard this from the general public. And even within our astronomical community, it's not always clear when we're really busy in our projects. A few months ago, a student asked me, why is this all important? Why is this important for society? Why do we do this? And so I thought, okay, this is a discussion it's worth having. Like, let's try to put this down in a bit of a more structured way. And so I came up with 10 points for why is astronomy important for society. Of course, I'm not going to be complete. I'm not going to be thorough either. I'm going to be basic, hopefully not naive. Let's go for these 10 points then. So number one, knowledge. So research makes knowledge, and knowledge makes us humans. This is something that I never really doubted as a researcher, and it's very deeply rooted in me. I hope many of you share this, but this is not something that resonates very much with the general public. People react much more strongly to fear. And thanks to science and astronomy, we moved very much away from a society that was dominated by fear and superstition. Imagine not knowing when and how and why an eclipse would occur, or imagine not knowing when and why and how a specific beam of light would come in and illuminate a very specific spot in a very sacred place. Here you can see some examples of some churches built several centuries ago. And these things were made by astronomers of the time to measure time, but they also helped to strengthen perhaps the awe and the fear of God. And a society that is full of fear, of course, is not a free society. So nowadays we moved on to a more open society of a more open science and open astronomy. So we have accessible education, not everywhere, unfortunately. We have accessible observations for astronomers, like at ESO, at Science Telescope, not everywhere. We have accessible data archives at ESO, at Science Telescope, not everywhere. We have standard data formats. We have reproducibility in most of the analysis that we do. We have a wonderful archive where we put our articles. We have a peer review in place, and then we have open access. Well, peer review, like we heard from a beautiful talk by Wolfgang Kerzendorf on Wednesday, and we heard about open access from Uta Grotkopf and Janina Bacescu. And I would argue that astronomy has somehow a special space or special position among sciences in this context, because things like having an accessible data archive or standard data formats or reproducibility of research or an archive. So it's not straightforward for other disciplines like chemical or biological sciences. Reason number three, why is astronomy important for society? For the protection of our Earth's environment. Protection from what? Well, one example is large solar flares. Stars have frequent flares, the sun less, but still, like once every 5,000 years, we should expect a very large flare. And these are things that really affect the atmosphere, satellites, power grids. Here you see an example of a picture, an example of a relatively large flare where the Aurora Borealis, the northern lights, came all the way down to Switzerland in 2003. And nowadays there are machine learning techniques to predict solar flares, like here the University of Geneva from the group led by Professor Lucia Kleint. Then we need to protect ourselves or monitor for near-Earth objects, so asteroids not far from Earth. And astronomers are busy in monitoring such objects. We discover something like 3,000 new objects per year. And we should not think that potentially dangerous events are so much unlikely or negligible. Like, in fact, in 1994, there was a large comet that impacted Jupiter, and that was observed by the Hubble Space Telescope. astronomers are part of an international asteroid warning network that, together with the Space Mission Planning Advisory Group, advise the UNOSA, so the United Nations Office for Outer Space Affair. And then a third thing that we need to protect as astronomers is the dark and quiet skies. We need to protect the skies from urban illumination and from the impact of satellite constellations in terms of trails, as you can see from this image here, and radio emission and space debris, for example. And talking about space debris, in 2 weeks from now, astronomers predicted that an old satellite that was lost will impact the moon. So in this discussion of the protection of dark and quiet skies, the main actors or the main stakeholders in the astronomical community at the moment is the International Astronomical Union, ESO, the SKA, others that I'm not aware of. And then on the UN side, there's the UNOSA, like the United Nations Office for Outer Space Affairs, and then the Committee on the Peaceful Uses of Outer Space. And interestingly, just this February, there was a proposal to COPUS to include astronomical research from ground and space as an instrumental part of space activities. So to me, this really proves like this interconnection and this intimate connection between astronomy and space activities. And I wanted to make another point here, that Earth observations, so observations of Earth from space, are fundamental for environmental sustainability. Another point of why is astronomy important for society is the technical transfer. So applications on Earth, Sandra already mentioned some earlier. So from the adaptive optics to, for example, laser eye surgery, or some imaging techniques for medical analysis like mammography or brain MRI. And then the isolation of radio signals, and something local here, Switzerland, like the detection of life signatures from some experiments, like polarimetric experiment that has been used then later to look for cancer diagnosis. And there's other examples. Then another reason why astronomy is important for society is that it can be directly used as a tool for sustainable development, as we heard from a lot from Sandra now. So the IAU has this beautiful office of astronomy for development, and it runs a number of projects, including the AstroStays, so ecotourism in Himalaya, projects with refugee camps in Algeria, favelas in Brazil, displaced children in Nigeria. But also there's other things like Astronomer for Planet Earth, and you will see the talk later by Leonard Bircher. And there's more smaller local projects, for example, the ESO-Art Nigeria that Wolfgang Kerzendock organized in 2018, or something I organized in Palestine in 2015. And of course, there's lots of projects going on from amateur astronomy, astronomers, and outreach, as we heard from Sandra. And going to space, UNOSA has a specific specific group monitoring what are the impacts of some satellite missions on reaching the on the sustainable development, and how can they help us to reach the sustainable development goals. Number 6, so a reason of why astronomy is important for society is to nourish the society's thirst for knowledge. They want to know about our universe, about our role in it. For example, starting from the basic things, life in the universe, what are the universe, stars, and galaxies made of. But my point is here that they want to know more. They know more. They get really, people care, and people know, like they can really get very specialized in the kind of questions they make, and get more and more knowledge, so much that they also run their own projects, for example, with citizen science. And here I wanted to make another point, that outreach is, of course, fundamental to get the knowledge that we produce with research to society. But also from what we heard from Sandra earlier, and also what we heard from Stephen Curry, we may be in a moment where maybe we are changing a little bit the social contract with society that we are having. Maybe we are not asked anymore just to provide reliable knowledge, but to be involved. So reliable knowledge, or that we make the knowledge and we give it to society, and that's like one way. But maybe we are changing this paradigm to one in which there's a discussion where we give input to society, and society gives input to science. So a higher level of participation of society in scientific activities, both in the production and possibly in the evaluation of our activities. One more point I wanted to make about this is about
Lisa, sorry,
topics.
5 more minutes.
Yes.
Five
Thank
more
you,
minutes.
Bruno. So, are more popular topics more valuable? Well, I think my answer is no. So we should keep in mind when we want to fund research, for example, or when we want to go from one topic or the other, that research leads to a known direction. Because when we start, we don't necessarily know where we get. And in this context, like a hot topic and a niche can be equally valuable. And I do know this by personal experience, because I was thinking that I was working on a niche and I ended up with a major discovery on the nature of galaxies. So another reason why astronomy is important for society is, of course, the logical and critical thinking that we bring in. So scientific thinking is needed in society. We know we have the scientific method, or even better, the critical rationalism from Karl Popper. We heard about this from David Merritt at the beginning of the week. So really, as scientists, we know how to handle data and information. We know how to process uncertainties. And this should be important for the decision-making, for the funding, and for society, or how to act, especially because we live in a vulnerable, uncertain, complex, and ambiguous world. My reason number 8 is for why astronomy is important for society is because research institutes shape the next generation. Well, large fractions of people in the EU attain tertiary education, so higher education, up to 60%. And in the EU, about 3/4 of the top CEOs have master's degree, and 1/4 a PhD. So really, I think that universities and research institutes form and shape people and leaders. So what we do in our department, it's really important to shape the next generation. What do people learn? What environment do they experience when they are in this higher education institutes? So what they learn and what environment they experience, they are likely to then bring out. In this context, and I think astronomy has or can give a very international and collaborative perspective. On the other hand, we need to decrease the harassment and strengthen diversity and well-being. And we heard many talks about this yesterday and throughout the week, both in terms of, well, here it's a plot for that shows harassment. You have seen this week already. Was a study done for the UK, but there's also a study from Germany, as we heard yesterday, and a recent publication on the well-being of French astrophysics. The reason number 9 why astronomy is important for society is its special perspective for sustainability. Now here, like the long-term perspectives, so the ones that are sustainable on the long run, they must be co-created by diverse disciplines and stakeholders. In other words, like if we are all concentrated in what we are doing, we may miss the larger vision, the bigger picture. So we need to reach out to other disciplines as well. So also astronomy, like we need to also zoom out and collaborate and make our own contribution. And here I left it open. I was really pleased to see during this week people from different backgrounds and disciplines, And I think this conference is very much into this direction. And I think it would be nice to. I would really be interested to hear what you have to say about this then later in the discussions. And reason number 10, of course, is that astronomy has a unique way of inspiring and unites humans because we all live under the same sky. So I would like to stop here. And please, if you have any feedback or suggestions on this, do write me. And I would like to thank you for your attention.
Thank you, Annalisa. Very nice. Thank you very much. Any questions or comments? I mean, Annalisa, I think you formulated many of the thoughts that we have, and you know, it's very nice for you to bring this together in this form. So that's very useful. Thank you. I don't see, actually, let me just check the YouTube. I don't see any question. Oh, there's a raised hand. Kevin Harrington. Sorry.
Hi, thank you very much. I just have a quick question on your comments regarding like the United Nations and their office and what would need to happen specifically from ESO's side, for instance, or the IAU, to really start to make, you know, stronger efforts to merge things and really try to reach things worldwide. You know, I think that it only makes sense for there to be a memorandum of understanding, at least, between such large organizations and big visions.
Yeah, so indeed, it's important that well, at both ends, like on one hand from the big organization, like the big stakeholders, but also like from the people, that we all get together, like, and tackle these issues of sustainability for society from the really different points of view. I'm not sure if I got a question or was more of a comment.
Well, if there was a collaboration between the Office for Astronomy in the United Nations and ESO, what would that look like, and how would that arise?
Yeah, this is
like a collaboration between UN and the International Astronomical Union or the Office for Development. Yeah, definitely. Yes, I think, yeah, that would be. I think this would really be important. Well, so then with UNOSA, then I think especially when astronomy is considered as a space activity, which is the current proposal, then there should be an astronomy representation within UNOSA, or at least in the conversation, like as for UN.
Yeah,
and I understand.
Sorry, go ahead, Kevin.
Bruno had
the DG and the ESO Council will, of course, have to approve of anything like this, but you know, what would have to spark this collaboration, you think?
Well, I think it's all sort of things that are at very high level that I don't grasp at this moment. But I would imagine that already if the proposal to COPUS for astronomy to be included as a space activity goes through, then already the dynamics will change. And I think that we are gathering some momentum already, like this conference is a probe of this. And I think that maybe it's a conversation we should have, and maybe we could, interesting to see what Bruno has to say about this, because maybe they already are discussing about this.
Well, no, but I think it would be a good topic that we could sort of pick up in the discussion again, because it needs a wider view, and it will be very interesting to hear from various people. I have a little bit of background, but I'm not involved in any of this right now. But we should do this then in the discussion. I'll make a note and pick that up. So thank you, Annalisa. In the interest of further discussions and coffee as well at some point, I should say, I'd like to move on. So thank you, Annalisa. And so we're
Thank you.
changing a little bit tack, I believe. So the next speaker is going to be Leonard Borcher. He's at the Leiden Observatory in the Netherlands, and he's going to tell us the connection between astronomy and the climate crisis. Leonard, same procedure. I'll give you a 5-minute warning at the end, 15 minutes. Okay, thank you.
Okay, thank you, Bruno. All right. So you should be seeing the start slide now. All right, thanks. Okay, so welcome everyone, and good morning, afternoon, evening, wherever you are. My name is Leonard Borcher, or Leo Borcher, and I'm going to talk to you about astronomy and the climate crisis. Of course, you hear this every day, so this introduction will be very short, but still I feel it's necessary to show some view graphs just to highlight the real emergency situation in which we actually are, and what we usually don't realize ourselves so much because life goes on, except for Corona, more or less like normal. But we really have the highest CO2 concentration since ever in humanity, and in the history of humanity at least. The latest number, as you can see here, measured usually on Mauna Loa, is 416.7 ppm CO2 concentration. And you can see here from reconstruction over hundreds and thousands of years that never in the recent history of Earth has such a high CO2 concentration been measured. And this is reflected in an ever-increasing temperature. As you also know, we have now reached more than 1 degree above the pre-industrial average. And it's very solid now that it's really us. It's humans who produce these, produce extra emissions, CO2 emissions, methane emissions, other greenhouse gases. And this is the driver for this increase in temperature. All the natural effects that happen as well, like solar variability or volcanic activity that can have a big impact on the climate, are really excluded at this point as a reason for this recent warming. And we have seen in recent years that this is not just something that happens somewhere to the polar bears in the Arctic or somewhere else, but it's really happening home. It's really happening very close to home, as we have seen in Germany the last summer, or increasingly also in, for example, the west of the US, and in many places, actually right now in Brazil, if you've been following the news with the big floodings there. So this is happening more and more everywhere. And it's really an urgency situation that you can see very nicely with this graphic. This is from the Carbon Monitoring Project, where they look at the absolute carbon emissions, the carbon dioxide emissions that can happen on Earth to limit warming to 1.5 degrees. And you can see how this bucket that would still limit warming to 1.5 degrees is filling up ever more quickly. And this is from 2019. And you can see that not a lot is missing before it actually starts to overfill or to overflow. And what would happen when it's overflowing is that the temperature on Earth, of course, would increase by more than 1.5 degrees. And we know that this would lead to dramatic consequences that we cannot even fully predict what it would be. So what does this have to do with astronomy? I mean, we're usually looking at stars and galaxies and planets. So what is our relation to this? Well, of course, we're human beings. We live on this planet. So that's the relation number 0. But also we have carbon emissions ourselves. And actually, as I will show in the next slides, astronomy is a very carbon-intensive, energy-intensive business. And so we should be interested in this relation and in solving the problem, at least for our own discipline. But also much more so, actually, as we have seen from the wonderful talks that happened just before me, that astronomy is a fantastic tool to convey this astronomical perspective, the fact that we're alone in this universe, as far as we know up to now, and that there is just this one pale blue dot, this planet that we have, and we have nowhere else to go. There is no planet B, is really our message, and we should convey it more and more to the public. And as a third point, I would like to mention here that we have a trusted voice. If we talk in the public about science topics, people like to listen to us. We give lots of outreach talks. We could probably do with more training, as Sandra was saying, but still lots of us are giving public outreach talks, and many do this very well. And so we can use this voice and we can talk about the current problem and say, hey, this is real. Our colleagues, the climate scientists, they are right. This is really a problem. Please take care. So our own carbon footprint. What emissions do we actually have in astronomy? This has been analyzed a lot in the last years, funnily, or for whatever reason, it has really started in 2020 with a number of publications. Might have been related to the first time that we organized a session at the EAS annual meeting to discuss this, but I wouldn't take just point at this was a number of incidences that came together. There were very few attempts earlier. For example, for the Decadal Report 2010, there was already a paper about low carbon or low energy astronomy, I think it was called, but that hasn't been followed up. So it was really in 2020 when these analyses started. And one of the first ones to be done was done by the sustainability group of the Max Planck Institute of Astronomy in Heidelberg, MPAA, by Knut Janke and collaborators. And they analyzed the emissions of their institute and found that 47%, nearly half of the emissions, are due to flying, due to air travel. Another a bit more than a quarter is from electricity consumption, which is actually lower than possibly expected, because apparently the city of Heidelberg is relatively green, uses a relatively green energy provider, or Max Planck, who uses the city of Heidelberg, etc., is relatively green. Then there's a bit for heating, commuting is only a small part, and some other things, including food and paper. They did not include all aspects, of course, but these are the main emission sources. And you can break this down into emissions per employee. This is 9 tons per person, 300 employees at this institute. And you can even break it down to papers. If you look at any first or co-author papers, then this comes down to 4.6 tons per article. So that's quite a heavy article. And you can also compare it to the average German citizen, and then it starts to get a bit tricky, because then you have to think about the difference between work-related and private CO2 emissions, so to say, and that's very difficult, because your own private emissions are, of course, someone else's work emissions. So that is a bit tricky, but you can see that the emissions here, 9 ton per employee, are using up essentially almost all of what the average the average emission per citizen is. So there's not much left, so to say, to go on holidays and run a house and eat. And you can also compare it to other countries. And for example, India here is almost a factor 10 lower in annual emissions as what is emitted by the average scientist at Max Planck in Heidelberg. We can also do this comparison in other places, and we did this recently for all of astronomy research in the Netherlands with the Raad van de Astronomie Green Team, led by Floris van der Tak and others. And we come to a very similar picture here. It's also the same colors. So here in our case, 42% in the Netherlands are due to flying, 29% from electricity, 15% from heating, a little bit more for commuting, and then the rest was taken into account was supercomputing. So that's also electricity, but at other places. And this can also be broken down, of course, per employee. This is only half as much as for the MPAA, but we're not comparing really apples with apples. So this is not to say that Dutch astronomers are greener than MPAA astronomers. Please don't take this conclusion away. These are really different measures. And but it might have to do with the fact that some more of the electricity is coming from green sources. So there's a lot of wind power in the Netherlands, more than in Germany at this point. You can also compare this to a big observatory. And for example, our hosts here, ESO, have been doing this analysis recently. This is published in the annual report of the latest one, I think still from 2020. And there you see a different picture, therefore also a different color scale here. So for the case of ESO, 41% actually comes from energy. This is mostly powering the telescopes on Paranal. Note, ALMA is not included in these numbers. Another 30% is from purchases. So all the electronics, computers, optics that are being used to build telescopes and instruments at ESO are being included here. And only 10% actually is from business travel. So that's ESO personnel themselves. I don't think this includes visiting astronomers. So this is really ESO personnel themselves traveling between mostly Garching and Santiago. And another 19% is other. This includes commuting within Chile and also to Garching and other places. So summarizing the emissions, we can say that the main emission sources in astronomy are electricity and flights. And it's relatively easy really to make electricity much greener than it currently is. You just have to install solar panels and use wind power. Really, it is as easy as that. Possibly some batteries for buffering. This is also available these days. So that is going to shrink a lot in the next years. And it's already shrinking. For example, in the Netherlands, the Dutch Space Research Institute, ASTRON, has just moved to a new building last year. And this is completely energy neutral in terms of electricity. So the whole huge carbon footprint of their electricity use has shrunk to 0. So that is very easy. For flights, it is not quite as easy. And therefore, let's look a little bit more into the flights. So we did this analysis for the Netherlands and found, similar to what other people have found before, that the majority of flights, if you can see my cursor, was within Europe, so for distances of less than 1,000 kilometers, but the majority of emissions is actually coming from the long distance flights. You can see this very clearly at the histogram at the bottom, that the blue line, the number of trips, peaks or reaches the 50% value at less than 1,000 kilometers, but the red curve that shows the emissions from all the flights reaches the 50% curve, the 50% point only at 9,000 kilometers.
Leonard, 5 more minutes.
Thanks. So it's the long distance flights that matter. We get a very similar picture from looking at the emissions of the EAS conference that we looked at last year. And there I just want to point out the number that if you did this conference online, as we did in 2020 compared to 2019, the emissions essentially are almost negligible or are negligible. They're a factor 3,000 lower. Another interesting factoid that I'd like to point out is work by Adam Stevens, who did a very comprehensive analysis for his institute and also for the whole Australian astronomy. And he found that flight emissions actually mostly come from senior scientists. You can see the red point here, or from postdocs, is already a lot lower. PhD students and master students almost don't contribute to this. So when people say, oh, we need these flights to do networking for young students, be careful, it's mostly the senior folks who do most of the traveling. Why should we care? Well, we are among the richest, so we actually are the ones who are producing these emissions. So there is an important point that we should actually care about our own emissions. Let me quickly in the last 5 minutes or 4.5 minutes go into the second part here. What can be done more? Well, I already said there is no planet B is really our message. This is really the astronomy message. There is no planet like Earth that we know. And even if there was one, we couldn't get there. And as someone pointed out, even if there was one and we could get there, who knows if the people there would actually like us? You know, it might be inhabited and then it wouldn't even be an option either. So that is clearly not an option. Of course, talking to astronomers, that's trivial, but still it's important to point out to others all the dreams about colonizing Mars and so on. It's all very nice and science fiction-like, but it's not an option, not an alternative for being careful with our own planet. We can use astronomy, as has been said before in this session, to convey a picture of Earth as, you know, as a pearl, as a marble in space, or the spaceship Earth idea that we really have this limited surface of this ball that we're living on, and all the emissions and all the things that we do stay on this planet. So we should be quite careful with the very limited resources that we have. And of course, we can give the wider perspective of what's happening, of what Earth is in the universe. And of course, this picture is the best picture to show. I mean, you've all certainly seen this many times, but I can only encourage you to show it also to your friends and non-astronomy colleagues. I'm always surprised how many people not know this picture, even, you know, well-educated people, and anyone has often not seen this picture, where of course Earth is this tiny point that's just 0.2 pixels from this Voyager 1 picture taken from behind Neptune's orbit. And that just shows how lost kind of we are in the universe, and how small the Earth really is, and therefore how important it is that we preserve this planet, the only planet that we have. So if we talk about climate science and the importance of preserving Earth and all the perspective and pale blue dot, who is it actually that we need to target our communication for? This has been studied a lot by the Yale program on climate change communication, a really very interesting research program that has been going on since many years now. And they did this first in the US, but now also internationally. And they look at the fraction of people who are alarmed, concerned, and so on about climate change. And many of us might believe that we have to actually convince people that climate change is real, that the science has to be taken seriously, and that you have to do something about it. So perhaps a little bit like the deficit model that Sandra pointed out in the beginning. And that is actually not true, as you can see here, because actually most people, this is true for the US, but also internationally, most people are actually already in the alarmed or concerned category. So you have more than 50% who are really alarmed or concerned about climate change, and another almost 20% who are cautious, meaning they're not yet fully decided, but they certainly know that it could be something real. So it's those people who we have to address our communication to, and not the few who are dismissive and who say this is just, you know, a Chinese lie or something. These are not the people who we need to convince. You will not convince them anyway. So it's better to get those people who already know that it's a problem to become active and to engage and drive the change that we need. In the last minute, I'd like to point out this organization that was kindly also already pointed out before. Astronomers for Planet Earth has been founded about 2 years ago, independently, first in Europe, first in the US and in Europe, more or less at the same time. And later we joined forces just a few months later. And now it's really an international organization with astronomers and astronomy communicators from all around the world. Over 1,300 people joined this organization. We have a mailing list, a Slack space, regular meetings, and we're just in the process at the moment to actually formalizing ourselves as a real NGO. So we're trying to get registered to also be able to accept funding. So in case you know someone who would like to give money to us, please let me know. And we do, we collect resources for outreach, but also organize really the kind of research into climate and sustainability topics within astronomy. And there's a number of papers that have appeared in the last 2 years, as I said, and you can all check them out and also download them, even if they were otherwise behind the paywall from our webpage. This brings me to the end, and I'll just leave up the summary slide, and thank you for your attention. And I would also like to thank the organizers, of course, for having me speak here. So thank you, Bruno and Giacomo.
Thank you, Leonard. So very interesting thoughts here. We have 2 comments in the chat, and so I thought Marie-Lou Chantron would be the first one to maybe comment what she had to say.
Hi, well, that was more for the previous talk, actually. So maybe we can come back to this right now.
Yes.
Okay. All right. Okay. So these are really great talks, but I'm just a little bit. It's like I was thinking that okay, we do have an impact in society in astronomy, and I think what was presented in the first talk was very like positive and everything. I just wanted to remind us that we do have an impact, and this was also presented in the current presentation, and that I hope that we all agree that we should like move on to something more, I don't know, peaceful and responsible, something like that. Yeah, I just wanted to highlight this, that we do have technological transfer that have not been that great, I guess.
Okay.
But yeah, I just wanted to highlight this. It's a bit weird, sorry, to be like,
no, that's fine. Thank you very much.
Yeah.
It's an important point to make, and thank you very much. But we also have a comment from Danish Travins, and that's directly to Leonard's talk.
Okay, yes. Well, obviously, one should be careful, and it's very important to limit resources and emissions and so on. But my criticism is that it becomes a somewhat, I think, misleading thing if one divides the emissions or impact of the entire ecosystem of astronomy by the limited number of research astronomers, like how much CO2 per published paper is coming. I mean, if you would take the James Webb Telescope, for example, and divide by the number of say, astronomers publishing papers, you'll get a very, significant number. But astronomy concerns many more people in the world than just those that publish papers. I mean, there are, I don't know how to define such a number, but it becomes somewhat misleading because these numbers are then compared with the private spendings of individual persons who are having, individual homes or many cars or so on. So this is just to balance. It's not astronomy is not something for a secluded, limited number of people. It is something for the much broader community. Thanks.
Yeah, that's a very good point. I agree that perhaps splitting it down into papers is not very useful. I would, however, push back a little bit and say that I think it is important that we think about our emissions in astronomy. I think you didn't disagree with this, Dennis, but it's not so much the total emissions. Of course, they are, of course, small compared to many other emissions, but that's part of the problem for the whole story about climate action. But you can always split it down into smaller and smaller entities, and then it doesn't matter anymore. I think we have to reduce our own emissions as astronomers, nevertheless, to show that we are really serious about this. Because if we don't do it, then how can we talk about Earth as a pale blue dot and as the marble in space and as being such a wonderful place and there is no planet B, and then hop on a plane and go to a conference in Hawaii. I think that just doesn't really fit together. So you have to walk the walk and just talk the how's it walk the talk. So to do what you say that you're doing, and that's, I think, the main reason why we should be careful and reduce our emissions.
Fully agreed, but the difficulty is, as Dennis is pointing out, I think, how do we quantify this in the end? I think you're absolutely right. Every one of us needs to think, do we need to do this? Is that travel necessary or not necessary? How we then quantify this in numbers, like the ESA report on sustainability and what we're trying to do, that is, difficult and can be part of the discussion. So we'll see that. In the interest of time, I really would like to press on. We have one more talk before the coffee break. Thank you, Leonard. And so Hannah Dalgleish is a scientist at Oxford University of Oxford, it says here, sorry. And she's going to give us another angle on being a citizen and astronomers as citizens, how we act in society. So Hannah, please take it forward.
Great, thank you very much for having me and for allowing me to speak on a topic that's very close to my heart. So my PhD was in astrophysics, so I'm not technically a proper social scientist or expert on cultural relations, but I will do my best. I've been working as a postdoc for the past 2 years on astronomy and sustainable development, so I have a bit of experience from that. So this work was inspired by an essay competition by the British Council, where they had suggested a few different topics, and I saw this one talking about partnerships for the Sustainable Development Goals, kind of thinking in the context of international collaborations for science and how they contribute to sustainable development and cultural relations. And I thought, wow, astronomy is such a perfect example for that. So I kind of submitted an abstract with the idea, and they really liked it, obviously. And it was also something that they never imagined was a thing. So I learned a lot about cultural relations, and the British Council got to learn a lot too. So there's a lot more in the essay than I'll be able to cover in this talk, but hopefully we'll cover the most important points. And so I was kind of initially trying to figure out what I would cover in this essay, and ended up down many different rabbit holes, and kind of started to realize just how kind of unique and important the history of collaborations in science and astronomy are, and how they've kind of led to where we are today. So I was learning about how in the 15th century you have researchers and scholars from all sorts of backgrounds, different cultures, religions, different parts of the world, that would travel at a time when travel is largely inaccessible, and they would travel to exchange ideas and meet with one another, and to compare data as well. And so that kind of feeds into this realization that actually the Copernican revolution is not as sort of Eurocentric as at least I had thought it had been, but really modern astronomy has its roots in a very diverse and cross-cultural exchange. And so if we skip forward a few centuries, we come to what I found to be the first example of international cooperation on a scientific project, and that's the Carte du Ciel. And what happened was about 20 different countries with observatories came together, and they wanted to map the entire night sky. And in order to do that, you require a lot of data, and you also require observations from both the north and southern hemispheres. And so that's kind of what led to this international cooperation. And They ended up with more than 22,000 plates, and it took many decades and it was never actually completed, but it's still a very significant mark in this sort of history of scientific collaboration. And so as these networks and collaborations were kind of already in existence, there became this sort of foundations for official organizations. So for example, there was the International Union for Cooperation in Solar Research that was founded in 1905 and came to a halt with the First World War. But that had already sort of then established itself as a network of many astronomers. And so they're already at the ready. So when the International Research Council was founded very soon after the First World War, there were two unions initially established, and one of them in geophysics and the other one the International Astronomical Union. So that's also very notable that the IAU was one of the first unions to be established, given this sort of already very international outlook and these pre-existing networks. And there are many challenges in the as time goes by with astronomy and collaboration. So of course the world wars, they resulted in the cancellation of many academic conferences, and it was very difficult to receive letters and journals. There were also challenges with the International Research Council and their sort of restrictions on which countries could become members of its unions. And a few astronomers were very kind of vocal about this and strongly opposed to the fact that former Central Powers could not join the IAU. And one astronomer in particular, he boycotted the ISE and the IAU for its lack of truly international outlook. And then eventually Germany became a member of the IAU in 1951. And then we have the Cold War, the Tiananmen Square protests, the Yugoslav wars, which resulted, there was the cancellation of the Leningrad GA. But it's also important to note that these were all politically neutral meetings and everyone was always welcome to attend them, regardless of where they came from and what culture they were and what political circumstances they might find themselves in. And so the main barrier to their attendance was that their own countries would refuse them to leave, or they were denied visas. And so I think this just really highlights just how sort of international the outlook of astronomers have been throughout the decades, if not centuries. And that's a really interesting thing to think about when we think about and compare to other sciences. And so astronomy collaboration today looks a bit different. We have several intergovernmental organizations, ESA, ESO, and the SKO. And we can also look at ways in which the infrastructure that come about because of these organizations and the funding that we have to therefore make telescopes and build these amazing technologies. And that it's not just about doing research and getting lots of data, but actually it's been found that these projects are really sort of providing a lot of training, a lot of capacity building, and as has already kind of been mentioned in the previous talks as well. Another interesting point is that there have been studies which show that astronomy, compared to other sciences, has the highest multinational authorship, which I thought was quite interesting. And also that astronomers don't only work with other scientists, but also with citizens as well. So you have lots of citizen science projects, which has resulted in many publications. So this leads again into sort of public engagement and the training and the development and just how dedicated astronomers are to doing this. So Sandra went into much more detail and illustrated this really well. But yeah, it's astonishing that 87% of IAU astronomers engage with the public in some way. When you compare this to other sciences, that's pretty high. And you have all of these training schools and all of these organizations which really have at its heart sort of this global outlook and cultural exchange. And I also wanted to note that the very existence that we even have an Office of Astronomy for Development is actually quite extraordinary in itself. And as far as I'm aware, like I haven't come across other examples in other sciences, but please correct me if I'm wrong. And so also something that's been mentioned a few times, yes, by Annalisa and also on previous days, is this thing about open access. And I guess I want to make a slightly different point as well, in that, yeah, the fact that all of these observatories like HST and WST, Space Web and VLT and so on and so forth, it's extraordinary that people from regardless of what country they're in or what institution they belong to, are able to apply for telescope time. And when you consider other sciences and that they, the funding is not easy to get for projects like this, for blue sky science. And so funders also typically would only ever allow people who had contributed to the project in some way, whether it's funding or in-kind support. It's pretty much unheard of that anyone could just have access to these kind of telescopes. And there's examples as well from this giant meter wave radio telescope in India, and how, because it's been open access, it's really helped them to sort of attract international, some of the best international researchers, and really help them to flourish in astronomy. And then again,
5 more minutes.
Okay. It's also not that common in other sciences that all the software and the data is publicly available either. So these are really quite notable things that astronomers strive to do. So I hope that kind of shows in different ways that really astronomy is this quite wonderful and globally inclusive scientific endeavor, based from our historical origins, kind of rooted in this cross-cultural exchange, how dedicated astronomers are to engage and train and work with marginalized communities, and just that as much as possible we try and keep things open access. This kind of led me to think as well in the essay. I sort of posed this question of, is it astronomy itself, the sort of inspiration that we have from the universe, that kind of makes us want to bring everyone together under one sky? Or is it the other way around? Is it the sort of dependence that we have on working together, collaborating to fund these big infrastructures, and also to need, both the northern and the southern hemisphere? Is that what kind of brings us together, and we're kind of forced to work with each other? So I'm not sure whether that's a question that can ever properly be answered, but it would be interesting to see if anyone has any thoughts on that. And so sort of coming back to the cultural relations aspect, I was trying to find a definition, and it's actually quite hard. There's not really any clear definitions of what cultural relations actually mean. But this was a nice one from a paper between the British Council and the Goethe Institute. The overall outcomes of cultural relations are greater connectivity, better mutual understanding, more and deeper relationships, mutually beneficial transactions and enhance sustainable dialogue between people and cultures. And I think that astronomy is a great way of goes to show that we kind of involve and do all of these kind of things and often maybe we don't really think about that. And I'm also aware that I have also painted a very rosy picture, and I go kind of into a bit more detail in the essay that it isn't perfect. All the things that we do are as one of the previous persons that made that comment, that there are definitely things that we can do better at. So I'll just end with this quote from South Africa's 1996 white paper on science and technology. So scientific endeavour is not purely utilitarian in its objectives and has important associated cultural and social values. It is also important to maintain a basic competence in flagship sciences such as physics and astronomy for cultural reasons. Not to offer them would be to take a negative view of the future, the view that we are a second-class nation, chained forever to the treadmill of feeding and clothing ourselves. So with that, I thank you.
Thank you, Hannah. Very nice, very, very interesting connections that you're making here. Thank you. Are there any comments? Yeah, you get lots of applaud here. So thank you, Hannah. Let me close this then for coffee so that we have enough time for coffee, tea, and other refreshments. Before doing so, though, I need to apologize to Peter Monroe, who actually put some comments into the chat on the YouTube channel, and I missed it last time. So Peter is pointing out that the CO emissions are important measurements, but he also says that the Earth is a complex system and we haven't fully understood everything. But he does say, and I think that's the important point, he says, can we find ways so that we have a guidance for us? Let me see whether I can read this. What additional steps can we take to protect our environment and what effects will they have? So he's trying to go slightly beyond the CO2 question. Methane is another issue that people can think about. So I think, again, it might be quite useful in the discussion that we maybe think of ways that we directly can take, being either political or in our personal lives, that we can help to protect this planet later on. So with this, let's break 15 minutes. So at the top of the hour, I suggest we come back, and that would take us right back to the schedule. That hopefully will give us enough time to have a good discussion later on. So thank you very much.